Welcome back to R for Investigators and Analysts. We're going to dive right into using R in a simulated investigation. And to keep it interesting, let's make it a homicide story we'll call Text M for Murder. Cheesy intro music aside, here's what we know about our case. According to the officers who responded to the scene, Dave Johnson returned home early from a business trip on October 16, 2017. He found his wife Susan on the floor, not moving. A man was standing over her body when Dave entered, but the suspect bolted through the rear sliding glass doors, jumped the fence, and then disappeared. Susan Johnson wasn't breathing when Dave called 911 and appeared to have been strangled. A thorough search of the residence has not produced Susan's mobile phone, which Dave claims she was never without. Now, as the primary account holder, Dave was able to provide consent to search the billing information for Susan's phone activity. But due to privacy laws, the mobile carrier will not release the content of the messages without a warrant. Their wireless providers return the billing records electronically, including call history, text history, and data usage. According to Dave, his wife texted far more than she spoke on the phone, so he suggested looking at her text first. Susan's phone number was 703-555-1760, and Dave's is 202-555-1219. You're assigned to review the most recent records for clues as investigators seek a search warrant for the content of the voicemail and the texts. Now let's go over to our investigative machine, which we learned how to set up in the introductory video. We have 3 files saved as CSV files. CSV stands for comma-separated value. We've saved them in a folder that we created just for this case. And now we're going to want to launch RStudio, or R console if you're roughing it, so we can begin analyzing the data. Now the first thing we want to do in RStudio is create an R project for this case, and we want to put that project and all of its associated files in our case directory. This way we can keep all of our evidence files and all of our derivative reports in one easy location. I'm going to hit Create Project, and it's going to fire up a new R project. I can see from the Files pane that I've now got an R project file along with my 3 copied data files, but I want to make certain that I'm reading and writing from the right working directory, so I'm going to use the command getwd. Notice all the R functions and in parentheses. This is where the argument would go if I was setting the working directory instead of getting it. Next, I'm going to read one of the files, in this case the text message information, and I'm going to store it in the variable text data. Notice the pop-up help for the read CSV command as I type. I need to give the command the file name, tell it whether or not it has a header, and then tell it to return a list of factors or not. In the extra material from last time, you can learn more about what these parameters mean, or you can just go to the help file. In this case, the file has a header in the first line that tells what all the variables mean, but I don't want it to return the list of factors. Now, in my Environments tab, I can see that I've loaded up the text data with 764 observations of 6 variables. I can even see what that looks like in RStudio by clicking on it, much like a spreadsheet. But let's close that out, and let's use R to look at the file more carefully. First, I want to get all the column names for the data that's loaded into my variable. Notice how RStudio helpfully offers to fill in the details as I type. My variable is a data frame, and it stored the data into named columns. Call names tells me the names of those columns. I can see just the first 6 lines of the data with the command head. This will return the first half dozen lines of the file with row numbers and column names. Since text data is a data frame, I can individually call out each column and treat it like a variable of its own. I can just add a $sign and the column name I want. Notice again how RStudio offers me a list of the names. I'm going to look at date, which gives me a list of all the dates listed in that column. I can look at just one entry by adding square brackets and a row number I want like this. I can call out a row and a column by number, row 5, column 4, or just get an entire row, row 4 for example. Now that I know how to slice and dice the data, I want to ask questions like, How many unique dates are captured in this data? Turns out there's a unique command, which I can find in the Help tab. In this case, I'm going to use unique to find out every date for which I have data about text messaging information. I could ask how many times I have information for, but that data is going to be quite large. One of the things that would definitely be of interest in this investigation are what are all the numbers that have exchanged messages with this cell phone. For that, I can look at the unique to and the unique from in this data set and find a list of all of the numbers. One of the things that I notice, there are a lot of duplicates in the data because the same number is represented different ways. Ultimately, that means we're going to have to clean up the data, but let's not go there quite yet. Let's review some of the other fields just to make sure we understand how to interpret everything we're seeing here. I can look at the field direction, and I see that I've got received and sent data. I can also take a look at the message type and understand that there are at least 3 different message types here: text, picture, video, and then something that just looks like maybe an unknown. But what if I want to ask how many times a particular entry appears? R has a function called table. Table automatically identifies each of the unique entries in a set and then counts how many times that entry appears. Table returns its values like this. I can see all of the phone numbers and the number of times they appear. And if I perform the same function on the incoming text messages, I get a table that looks slightly different. This might make you think of a different way of representing this data, a more visual way, and R doesn't disappoint. R's bar plot command can easily turn this table object into a bar graph. If I put the same table of outgoing numbers into the bar plot function, it draws me a very simple graph. You'll notice there are a lot of different parameters we could set when you look at the help file, but let's just try it straight up with nothing set. The default parameters aren't very useful. I need to change the look of this a little bit. But before I start doing too much to this data, I need to start keeping a record of what I'm doing. I'm going to create a new R script that will serve as an executable record of what I'm doing to the data. There's another way to capture this, one that I think is better for this type of work, but we'll start with the basics before we get into anything fancy. To change the margins of the graph, I need to alter some of the defaults for plots. They're stored as parameters using the par command. The parameter I'm changing is the plot margin, or mar. Margin wants to know how many character lines to leave as spaces at the bottom, left, top, and right margins respectively. In this case, I want to give myself a lot of space at the bottom, and I know I'm going to want just a little extra distance, so I'm going to add 0.1 to all of these. This par command looks a little strange, but what I'm saying is put the old parameters in the variable op and then change the margins. I also want to rotate the labels to make sure they're perpendicular to the axis, so I set a label style LAS to 2, and I'm going to set a main title for each one of these. The last line of the code will reset the margins to the way they were before, which just helps keep things clean. And as you can see, when I run the script, I get 2 much more readable bar plots, and I can start to see where I really need to focus my analysis. Next time, we're going to see how to clean this data up and start to find real clues about who the victim had been texting and how that might relate to the murder. Once again, check out the materials in GitHub so you can do these steps for yourself, and hit me up on Twitter or LinkedIn if you have any questions or comments. Thanks for watching.